Woohoo! Welcome back. Today we're going to be working with sequences and summation. Yay! And we're here with my friend Squirrel, and I think Squirrel is here because he thought we said sequins instead of sequence, and he was very excited because he's always up for sequins and dance parties. So we will try to have a dance party by the end of this video. But for now, we're going to be working with sequences. So, a sequence is a list of numbers in a certain order. And we've been working with these all along. We just didn't have a name for it. A1, A2, A3, A4, dot, 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 dot is ellipses. It means some other stuff. And then you notice we get to A sub n minus 1, A sub n. And then, interestingly, instead of stopping, we have another ellipsis there, which means it keeps going. And in this book, all the sequences will be infinite. So some books start off with finite sequences, so it would be a list of numbers that stops. This book skips that and goes, you know what, let's just go for infinite sequence. So yeah, let's do it. A1 is the first term of the sequence. This is throwing down in a particular way. Some folks start counting from A sub 0. So this book is going to count from A sub 1. So that's the way we will do it. But be flexible. Sometimes you start from 0, sometimes you start from 1. Okay, a sequence can be a list that appears to be random. And I'm going to say appears to be random. And here I'm going to say something that you may or may not agree with. But in my mind, I don't think humans can make a quote-unquote random list. I think that we have internal biases. We have things we like, things we don't like, and so our lists can't be truly random. But I did attempt to write down just kind of whatever numbers came to mind, which you can see it kind of bops around a lot, and it does appear to be random. And I'm sure if we worked really hard, though, we could find some sort of interesting pattern happening because I invented it. I wrote it down myself. But for what we're going to be doing, we're going to be working with sequences in the book that appear to have a very clear pattern. And so we're going to start off with this first sequence, 2, 4, 6, 8, 10, 12. And the question is, what is the formula for the general term A sub n of that sequence? And in order to do that, I'm going to go ahead and write down the terms. So in other words, A sub 1 is 2. A sub 2 is 4. A sub 3 is 6. Now, do you see a relationship between the counting number, the label, or the first, second, or third with the actual term itself? And I would say, let's look at this. 1 goes to 2, 2 goes to 4, 3 goes to 6. Let me try a couple more. A4 is going to be 8. A5 is going to be 10. I think AN is going to be 2 times N. What do you think? Right? So we can check it. A6, what should A6 be? It should be 12. Is it 12? And the answer is yes, it is. Okay, so that's our general term. And is it possible to have more than one possible general term? And the answer is yes. So when I say find the formula, we're generally looking for the simplest one, because I could come up with some interesting ways to work around this and make it much more complicated. That's not what we're going to be looking for. We're always going to be looking for what we can, if we can get the simplest formula possible. So, next up, if I did one little thing, now take a look at this list, and then take a look at this list. How is this sequence different from this sequence? And the answer is, this sequence starts with 0. So now we have A sub 1 is 0, A sub 2 is 2, A sub 3 is 4, and that is going to be a lot more complicated, right? Because 2 going to 2, well, that's the same number. 1 going to 0, that got smaller. 3 goes to 4, that goes bigger. So this is a complicated question. A sub 4 is 6. A sub 5 is 8. And what I would do, the way I would suggest that we look at it, is we imagine, instead of trying to just look at this, I'm going to say, I've got 2, 4, 6, 8, 10, 12, which has my, oh, that's not what I meant to do. Sorry about that. Oh my goodness. Oh my goodness gracious. So that goes to 2n, and now I've got 0, 2, 4, 6, 8, 10, ... What is it? What is its general formula? And I'm going to look at the relationship between each term of the old with each term of the new. And it seems to me that I just take whatever I got before, the 2n, and I subtract 2. The other way to look at it is that it could be that it's 2 times the quantity n minus 1. So you could have seen that these terms, there could be different arrows. So you could look at the relationship in 2 different ways. So it could either be 2n minus 2 or 2 times the quantity n minus 1. Woohoo! Okay, so let's take a look at some other things. Woohoo! So we're going to find a bunch of formulas, and again, we're going to look for the simplest formula, and our friend Squirrel will be here. Squirrels are great at finding things that are hidden, so let's hope that the group of us, we can get this. And we're going to find the formula for the general term. I'm always going to recommend that you write them out either like this, or if you've got the list written out, you could write like this. Now, this one is not the hardest one in the world, right? Because a sub 1 is 1, a sub 2 is 2, a sub 3 is 3. Wait a minute. It's just whatever that number is, the counting number there, it's that value. So a sub n is just whatever n is. But I'm always going to recommend that you write it out so that your eyes can actually see the correspondence. Not everybody needs this, but I think it's a good idea. So consider that unless the pattern comes to you immediately. Okay, this one's a little bit more exciting because this one does something. It's called alternating. There's negative and then positive and then negative and then positive and then negative. And we're going to assume it continues on like this. So a sub 1 is negative 2. A sub 2 is 4. A sub 3 is negative 8. A sub 4 is 16. And a sub 5 is negative 32. There are 2 things going on here. Well, there are 3. There's bunny fur. Let me move the bunny fur. And then there are 2 other things going on here. If you're a computer scientist or someone who works with base 2 a lot, you may already see what this pattern is, part of it. Because we've got to deal with the fact that it goes negative, positive, negative, positive. But then we also have 2, 4, 8, 16, 32. It's getting bigger by 2s. And in fact, it's getting bigger by negative 2, right? We're multiplying each time by negative 2. You see how that's working? So, and I should write times negative 2 times negative 2 times negative 2 times negative 2. And so this is one way to look at a sequence and to try to figure out what the pattern is see how each of the terms are changing. But you might have also noticed it from 2 to the first power is 2 with a minus in front. 2 squared is 4. 2 cubed is 8, but there's a minus in front. 2 to the 4th is 16. 2 to the 5th is 32, and then we've got a minus in front. So then we could try some different things. So we could say a to the n equals 2 to the nth. And this would give us 2 to the 1st, 2 squared. Let me scooch this over a little bit. Pardon me, squirrel. 2 cubed, 2 to the 4th. So that would give us 2, 4, 8, 16. Is that correct? And the answer is it's very close, but we don't have the alternating. We don't have the minuses coming in every now and again. So what we could try is either you could take this and multiply by a -1, or as this was suggesting, what if we tried a sub n is -2 to the nth? Now, just because your brain is sure it might be correct doesn't mean you shouldn't check it. So let's look. A sub 1 would be -2 to the 1st, which would be -2. Good. A sub 2 would be -2 squared, which would be -2 times -2, which would be +4, and that's correct as well. A sub 3, -2 cubed, that would be -8. So, woohoo, we have a winner, yay! Happy squirrel, happy squirrel. Okay, shall we try another one? These are hopefully kind of fun because they're puzzles. They're fun until they're not, right? I guess that's the way math is. Dun, dun, dun! Speaking of things that are fun until they're not fun anymore. Oh, no. Now, the great thing about this is that we can approach this in pieces. The numerator and the denominator don't seem to be related. The numerator has an alternating thing going on with pluses and minuses. It also seems to be 3, 4, 5, 6, 7. That seems to be a very standard progression, right? It starts at 3 instead of starting at 1, but basically we know what's going on there. Now, down in the denominator, it helps if you have a calculator. Because if you have a calculator, then you'll be able to see that this is 3 over 5 to the 1st, -4 over 5 squared, 5 over 5 cubed, -6 over 5 to the 4th, and 7 over 5 to the 5th. And then we can see, aha, okay, so a sub n is going to be something over 5 to the nth. What do you think? So you can approach these things in pieces and try to get part of it. So we've got part of it. I feel pretty confident the denominator is just powers of 5. Woohoo! Yay! Okay. So now I've got to connect a sub 1 to 3, a sub 2 to -4, a sub 3 to 5, a sub 4 to -6. Now, I'm seeing that each one, if I ignore the signs, so I ignore the minuses, I see 1 goes to 3, 2 goes to 4, 3 goes to 5, 4 goes to 6. It's 2 bigger. So I think what I have is I have an n plus 2 part of it, right? Because n plus 2 would give me, for a sub 1 would give me 3, for a sub 2 would give me 4, a sub 3 would give me 5, a sub 4 would give me 6, etc. Right? So, okay, so there's an n plus 2 component. So now my a sub n is something n plus 2 all over 5 to the nth. Right? But what do I have to take care of? I have to take care of this minus. Now, previously, the way we got the minus was just making it -2 raised to the nth power. So, what if I just used -1? Oops, I can't bring it too far out. So, So I'm going to write, And so here's where I get to come in and say, well, I know something about how to do this sort of thing. If I do use -1 to the nth, then I get for n equals 1, I get -1 to the first, which is -1. For n equals 2, I get -1 squared, which is +1. Cubed, -1 cubed equals -1. For -1 to the fourth, which is +1, and so on and so forth. Okay, is that what I've got? And the answer is no. That is not what we have. Okay, what we need to do is we need to push it sideways, because we want the positive. We want 1 to give us a positive and 2 to give us a negative. So what if we took -1 to the n plus 1? Then we would get -1 for n equals 1, 1 plus 1, so that's -1 squared, which gives us the positive. And for 2, we'd get -1 to the 2 plus 1, so that's -1 cubed, which is -1. And that's how we shift. Instead of starting with the negative, we have the negative come in second. So our final form will be the -1 to the n plus 1. That will start the alternating. That will allow it to go positive, negative, positive, negative, positive. Then we're going to put in the n plus 2, and that will allow the numbers to go 3, 4, 5, 6, 7. And then down in the denominator, we would go 5 to the nth. And that's going to be our final answer. Now, are there other ways to do this? Absolutely. I can think of a couple other ways to do this. It will be slightly different. So there are multiple ways to do this, so don't get too frustrated. And if you're having trouble coming up with ideas, definitely practice. But talk to me, talk to the tutors. I know I'm a broken record about this, but we are so happy to help. And I realize that this is a different kind of puzzle that we haven't really worked with yet this semester. So it's the end of the semester and you're feeling stressed out. And here I am saying, be creative, solve puzzles. And your brain may just want to be applesauce right now. So I totally understand that. So reach out for help. And I'm going to stop here, and then we're going to go into more sequences in the next video. Woohoo! Yay! Math on and woohoo!